Hello students, how are you all? I hope all are fine and enjoying summer vacation. So today we are going to study a chemical reaction and equation part 2. So first part you have seen, there we studied about the chemical introduction, about chemical reaction, chemical equation means what, isn't it? We studied about that. So today we are going to study the types of chemical reaction. So there are so many types of chemical reactions are there. So we'll study one by one. So let us start the class. So here you can see something in the picture, isn't it? Slide. So there is one white powder and the water is adding to that white powder. So we get a solution of that white powder. And by seeing the picture, you can see that white fumes are coming out of that. Yes, right? So that is nothing but, and you can also see the chemical equation here, that is nothing but calcium oxide plus water give rise to calcium hydroxide. So this is what called as chemical combination. So the first type of the reaction is chemical combination. Chemical combination is nothing but, see the equation here, there is only white powder. White powder is nothing but calcium oxide and water is added and we get a calcium hydroxide. I'll give one more equation, that is nothing but burning of coal. Okay, when carbon is heated, burnt, what happened? Carbon dioxide we get. Carbon dioxide we get. So this is an example for combination reaction. And in the previous reaction you also studied calcium oxide plus water give rise to calcium hydroxide, isn't it? See the both the reaction, in both of that you can see that, see some of the reactants, there are two or more reactants reacts to give a single product. Reactant means what? Which are reacting with each other, isn't it? So how we can define the combination reaction? In a chemical reaction, if two or more reactants reacts to form a single product, then it is called as chemical combination. Then it is called chemical combination. Okay, then it is called chemical combination. So what is chemical combination? Chemical combination is nothing but when two or more reactant reacts to form a single product. So that is what called as chemical combination. So along with chemical combination you can write also one more equation, that is nothing but H2 plus O2 give rise to H2O. Here H2 and O2, they are the reactants, and after arrow mark whatever is there, no, that is called as a product. I hope what is chemical combination, I hope you understood what is chemical combination, isn't it? What is chemical combination? If two or more reactants to form a single product, this is the general form of the chemical combination, two reactants and one product. Okay, now we'll see what is exothermic reaction. So another type of a reaction, exothermic. See here, when water is added to calcium oxide, we get a calcium hydroxide. Okay, we get a calcium hydroxide. Now this is, see there a lot of, and you can see the fumes are releasing out, it is nothing but heat is released there, isn't it? So during chemical reaction, if heat is released, then it is called as exothermic reaction. Now a same equation we can write CaO plus H2O give rise to CaOH2. Now Ca, calcium oxide, is there, no? That is called as a quicklime, and calcium hydroxide is called as a slaked lime. Okay, slaked lime. Now calcium hydroxide is used to whitewash the wall. It is used in whitewashing the walls. Okay, it is used in whitewashing the walls, and after whitewashing you can see that shinier surface, no? After 1 day, after 1 or 2 day, you can see that walls are shining. That is because this calcium hydroxide, they react with the carbon dioxide present in the atmosphere and they form calcium carbonate. Okay, they form calcium carbonate. And one more thing, that you may have seen the Taj Mahal, isn't it? That is made up of white marble. So the white marbles, chemical formula of white marble is also same, that is nothing but calcium carbonate, CaCO3. Understood? Exothermic reaction. Exothermic reaction means what? Like in a chemical reaction, if heat is released, then it is called as a exothermic reaction. First example is calcium oxide, that is quicklime. When it is reacted with water, we get a slaked lime. And along with that, one more that I already gave carbon oxygen give rise to carbon dioxide. When coal is burnt, we get a carbon dioxide, and along with that energy is released, heat energy is released. So that is what called as what? Exothermic reaction. Burning of coal, when something is burnt, we cannot touch it because heat is released there, isn't it? Thermal. Therma means what? Heat. Therma means heat. Exo means exit. Okay, so what is exothermic? Heat is released, heat comes out from the chemical reaction, so that is called as exothermic reaction. And one more example for exothermic reaction is respiration. Okay, one more reaction is what? Respiration. What is respiration? Respiration is nothing but whatever we eat, carbohydrate content, no, that will convert it into glucose. Formula of glucose is C6H12O6. When glucose reacts with oxygen that we intake during a breathing, the oxidation of this will take place and we get carbon dioxide, water and energy. Okay, we get water and energy. So this is an example for respiration. Now you may ask how it is exothermic reaction, how we come to know that. Now just keep your finger near the nasal cavity. Nasal cavity andre ಮೂಗಿನ ಹೊಳ್ಳೆ ಉಂಟಲ್ಲ, ಹೊಟ್ಟೆ, ಅಲ್ಲಿ ನೀವು ಜಸ್ಟ್ ಕೈ ಇಟ್ಟು ಬ್ರೀದ್ ಔಟ್ ಮಾಡಿ. ಸೊ ನಿಮಗೆ ಬಿಸಿ ಗಾಳಿ ಬರೋದು ಕಾಣ್ತದೆ. ಸೊ ಯು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ದ್ಯಾಟ್ ವಾಟ್ ಹಾಟ್ ಏರ್ ಇಸ್ ಕಮಿಂಗ್ ಔಟ್. ಸೊ ಅಲಾಂಗ್ ವಿತ್ ದ ರೆಸ್ಪಿರೇಷನ್ ವಿ ಆಲ್ಸೋ ರಿಲೀಸ್ ಅ ಎನರ್ಜಿ, and those energy are used for the various activity, and some when we breathe out means when we exhale it comes out. Okay, so that is about the respiration reaction. And one more, this thing, what you know, decomposition of the organic matter. The third example I can write is decomposition of organic matter. Now what do you mean by organic matter? It is nothing but plant and animal source. Is called as organic matter. Decomposition means what? Breaking down. Okay, breaking down. So what happens when the anything fallen leaves, they will decay, isn't it? Or anything animal if died and all, they will decay later. So during that process also what happens, heat is released out. Okay, so that is what called as decomposition of organic matter. Decomposition of organic matter. So we have learned the three example here. One is calcium oxide, that is nothing but quicklime. When it is react with water, we get a slake lime. That is one reaction. And burning of coal, second reaction. And respiration, as example we learned. And one more is decomposition of organic matter. That is about the third or fourth reaction. So this is what exothermic. Exothermic means what? Release of heat. Okay, next we'll go to the next slide. Just check here what is going on. They have a powder that is a green color, pale green color powder, and it is added to the test tube. Color of the powder is pale green. Okay, now this powder is nothing but ferrous sulfate. What is that? Ferrous sulfate. Okay, ferrous sulfate, and it has a water content in it. It is nothing but 7H2O. 7H2O. Okay, so this is ferrous sulfate. See, we'll see what happens. They are added to the test tube. Next slide we'll see. See, and they are heating here. Okay, they are heating this by using a burner. So what happens when they heat? When they heat, the color of the salt changes into a brown color. Previously it is what? A pale green color, but now what happens? The color of the powder changed to brown color. Now why this kind of reaction takes place? We'll see what is the reaction. So what happens is, here I'll write the equation. Okay, ferrous sulfate is heated, ferrous sulfate formula 7H2O is there. 7H2O. When it is heated, okay, what happened? Ferric oxide, Fe2O3 plus SO2 plus SO3. Sulfur dioxide, sulfur trioxide. Sulfur dioxide, and this is sulfur trioxide. Okay, sulfur dioxide and sulfur trioxide we will get. So what happens here? Here, when we heat the substance, it will decompose, means it will split into two or many product. That is what the example for decomposition reaction. Okay, decomposition reaction. So what is decomposition reaction? In a chemical reaction, if one reactant split into two or many products, then it is called decomposition reaction. Okay, decomposition reaction. Example is ferric sulfate. When it is heated, what happened? Fe2O3 plus SO2, sulfur dioxide, and sulfur trioxide we got. And one more example, calcium carbonate. When it is heated, calcium carbonate, we get calcium oxide plus CO2, calcium dioxide. Okay, so and this calcium oxide is there, no, and this is used in a manufacture of cement. This is used in a manufacture of cement. Which one? Decomposition reaction. Means in decomposition reaction, calcium oxide is used in manufacture of cement. Okay, so here what happens? Here we'll see what happens here. So we learned what do you mean by decomposition reaction, isn't it? Decomposition reaction is nothing but in a chemical reaction, if one reactant split into a two or more many product, then it is called as a decomposition reaction. Now decomposition reaction is divided into three types. Okay, decomposition reaction is divided into three types. One is thermolytic decomposition, and the second one is electrolytic decomposition, and the third one is photolytic decomposition. Okay, thermolytic decomposition, electrolytic decomposition, and photolytic decomposition. We'll see what you mean by each of the term and example for that. So first one, you can see here, you can see something they are holding by using a pair of tongs, and it is heated. It is nothing but lead nitrate. Okay, it is nothing but lead nitrate. When lead nitrate is heated, so what happens? It is a white color powder. Okay, lead nitrate is white color powder. Color of the powder is white color. When it is heated, what happens? We get a brown fumes here. See, you can see the fumes here. The color of the fume is brown color. So we get lead oxide plus NO2 plus oxygen. Okay, we get lead oxide and NO2 and oxygen. So the color of NO2 is brown. The color of the brown fumes are there, no, that is nothing but because of NO2. Okay, because of NO2. So here what happens? Decomposition reaction takes place by means of heat. Okay, so what happens? Decomposition reaction takes place in the presence of heat. Decomposition reaction takes place in the presence of heat, then it is called as a thermolytic decomposition. Then it is called as thermolytic decomposition. Okay, thermolytic decomposition. Thermolytic decomposition is important. So I hope this much you understood. Okay, we'll go to the next slide. Here you can see there is a two test tube, you can see, isn't it? And you can see that what switch is there, battery is there, isn't it? So this is an example of electrolytic decomposition. Electrolytic decomposition is nothing but, so this picture is this one is there in your textbook by using that mug and all. Okay, like this, a mug that here you have to take this kind of example is there. Okay, this kind of example is there, you just check it. Okay, go through that, you'll get to know about that. Okay, now we'll understand what is this. So here what happens is, you can see here battery is there, one side is positive side and the other side is negative side. Okay, so positive side is there, no, a negative side you can see, right? See, this is a negative side. Which one? This side is there, no, this is the negative side and this is the positive side. Okay, negative side and the positive side. Okay, so what happens here? Now here water is taken in this you can see the beaker here. Water is taken, and to that water they'll add a few drops of HCl. For HCl, to get a what's this one, okay, ions, they'll add a HCl. Now what happened when the HCl and when they pass the current, see when they on the current, so what happened means when they on the switch, what happened here, the water is split into H2 plus O2. Okay, water will be split into H2 plus O2. So this is called as what? Electrolytic decomposition. Like decomposition reaction takes place in the presence of electricity. I'll write here. Decomposition reaction takes place in the presence of electricity is called as electrolytic decomposition. Okay, now see here which gas is released to the plus side and which gas is released to the negative side. Negative side hydrogen gas is released and positive side oxygen gas is released. Okay, so you can see where there is the more space, no, that side hydrogen gas is released, and where there is less space, there oxygen gas is released. Now why this oxygen is more and hydrogen is less, why hydrogen is more and oxygen is less? Why? Because if you write the one molecule of water, so there the amount of hydrogen is more than oxygen, isn't it? The amount of hydrogen is more than oxygen. So what happened? The more amount of hydrogen gas is released and less amount of oxygen gas is released. So that is about the electrolytic decomposition. So now third example, or the third type of decomposition, that is nothing but, you can see here there is a white powder. This is nothing but silver chloride. Okay, when it is exposed to sunlight, here you can see a powder, color of the powder turns into gray. That is nothing but when it is exposed to sunlight, they release, means they will split silver and chlorine. Okay, silver and chlorine. Same way, if you take silver bromide, that same thing you get, silver plus bromine. Now this decomposition reaction is carried by sunlight, so such type of decomposition is called as photolytic decomposition. Means, I'll write the definition. In a chemical reaction or a decomposition reaction takes place, the decomposition reaction takes place in the presence of sunlight, then it is called as a photolytic decomposition. Understood? So at this one, AgCl and Br are used in, okay, this solution is used in black and white photography. This is important. Both solution is used in black and white photography. Okay, they are used in black and white photography. Their uses also comes because based on this they can ask the application level question. I hope this much you understood. So we learned the three types of decomposition. One is thermolytic decomposition, electrolytic decomposition, and the photolytic decomposition. Next type, that is nothing but displacement reaction. As you can see here, there is a solution, blue color solution, that is nothing but copper sulfate solution. and they kept a iron nail on it, isn't it? Iron nail, and the color of copper sulfate solution is blue. After some times, the color of the solution turns into a pale green. Color of the solution turns into a pale green, and if you observe that iron nail, you can see the brown color powder is present on that. Now what happens to this? When copper sulfate reacts with the iron, this iron displaces copper sulfate and forms ferrous sulfate, and copper will be deposited on the iron nail. The brown color powder is nothing but copper, and pale green color solution is nothing but ferrous sulfate. So this kind of reaction takes places here. In a chemical reaction, I'll write the definition. Okay, I'll write the definition in other color. In a chemical reaction, where more reactive element displaces less reactive element, then it is called as displacement reaction. Understood? Displacement reaction. In a chemical reaction where more reactive element displaces the less reactive element, then it is called as a displacement reaction. So there are so many examples for displacement reaction. One more example is nothing but Zn. Okay, when zinc is kept in the solution of copper sulfate, we get a solution of zinc sulfate and copper. Now here this is more reactive element, and compared to iron, copper is less reactive. Okay, less reactive. Can you tell me in the second equation which one is more reactive and which one is less reactive? Here zinc is more reactive and copper is less reactive. Okay, I hope this much you understood displacement reaction. Next we'll go to the other type, that is nothing but double displacement reaction. Here you can see they have taken a two test tube. Okay, there is a two test tube. In one test tube they have taken a sodium sulfate solution, and in the other test tube they have taken barium chloride. When barium chloride is added to sodium sulfate solution, see, when it is added, the color turns into white color. So we'll see what happens. So sodium sulfate react with the barium chloride, give rise to sodium chloride plus barium sulfate. Okay, barium sulfate. Now the color changes white because of the presence of barium sulfate. Okay, color changes white into because of the presence of barium sulfate powder, and here this white color whatever is there, that will settle at the bottom. Okay, this will settle at the bottom. So double displacement reaction is also called as precipitation reaction. First I'll write the definition of double displacement reaction. In a chemical reaction, if ions are exchanged, then it is called double displacement reaction. Okay, this is called as double displacement reaction. Just go through this. Okay, double displacement reaction. And why it is called as a precipitation reaction? Precipitation reaction means in a chemical reaction, if undissolved substances formed, then it is called as a precipitation reaction. Then it is called as precipitation reaction. Okay, precipitation reaction. What is precipitation reaction? In a chemical reaction, if undissolved substances are formed, then it is called as a precipitation reaction. You can give one more example for this. That is nothing but lead nitrate. That we took lead nitrate and potassium iodide. The color of the solution turns yellow color because of lead iodide. Okay, lead iodide plus potassium nitrate. So this is one more example for double displacement reaction. Okay, I hope this much you understood. Next we'll go to the another type, that is nothing but oxidation and reduction. Now oxidation and reduction, see here is a brown powder is there, that is nothing but copper. Okay, when it is heated we get a black powder, that is nothing but copper oxide. So when copper is heated we get a copper oxide. Now here you can see the two name, oxidation and reduction. Now what is oxidation and what is reduction? Now I'll write first what is oxidation. Okay, so first we'll understand what is oxidation, then we'll go to reduction part. Oxidation, so here it is nothing but oxidation means addition of oxygen or removal of hydrogen or electron. This is called as oxygen. So if oxygen is added to a reactant, then it is called as oxygen. If hydrogen is removed from the reactant, then it is called as a oxidation. Now oxidation you understood, no? Then we'll see what you mean by reduction. Okay, reduction is totally opposite to this. It is nothing but removal of oxygen or addition of hydrogen or electron is called as reduction. Now example, this CuO is there, no? Copper oxide. When it is react with, when hydrogen gas is passed, here H2O and copper is formed. So this is water reduction. A hydrogen is removed. Now which one is oxidized here or which one is reduced here? Now this one is reduced. Hydrogen is removed from here, no? So this substance is reduced. Which one? Copper oxide is reduced. Now this substance is oxidized. Now we'll write one more type, that is nothing but redox reaction. It is nothing but in a chemical reaction, if one substance is oxidized, and another is reduced, then it is called as a redox reaction. Then it is called as redox reaction. Okay, so this kind of reaction is called as redox reaction. Now what do you mean by redox reaction? In a chemical reaction, if one substance is oxidized and the other is reduced, then it is called as a redox reaction. We'll write one more thing here. the substance which is oxidized and substance which is reduced. I'll write the example. Fe2O3 plus 3CO give rise to 2Fe plus 3CO2. Now you might be confused. Now both the side oxygen is there, but just check. Sometimes it might be one oxygen is also added extra, then it is called as oxidation. See here, reactant side Fe2O3 is there, ferric oxide. Later in the product side Fe is there, means what, oxygen is removed from here, isn't it? So this is reduced. Here there was no only one oxygen, but later here what happened to oxygen? So this substance is oxidized. Understood? The substance which is oxidized and substance which is reduced, that is called as redox reaction. One more. Now oxygen we learnt. We'll see how about the electron. Fe plus S give rise to FeS. Now you should know that metals always donate the electrons and non-metals will receives the electron. The removal of electron. So which substance is oxidized here? Fe is oxidized. And S is reduced. I hope this much you understood. Okay, oxidation means what, reduction means what. And one more concept, that is nothing but oxidizing agent and reducing agent. So I'll write oxidizing agent. This is nothing but substance which oxidizes other substance is called as oxidizing agent. Then what do you mean by a reducing agent? Reducing agent is different. Okay, reducing agent I'll write here, reducing agent, the substance which reduces other substance, is called as reducing agent. Now in this two equations, which one is oxidizing substance and which one is reducing agent? Now the substance which oxidizes the other substance, which substance was oxidized the other substance? The substance which get reduced, isn't it? So in the first reaction, Fe2O3 is a oxidizing agent. Okay, it got reduced itself and it oxidizes the other. No, so that is a oxidizing substance or the oxidizing agent, means it itself get reduced. So the substance which itself get reduced and oxidizes the other, see it donated its oxygen to carbon oxide, isn't it, carbon monoxide. So this substance is oxidizing agent. And in the second equation, which one is oxidizing agent? The substance which is reduced, I told, isn't it? So S. And here which one is the reducing agent? Carbon monoxide, and here Fe. So this is about oxidizing agent and the reducing agent. Next we'll see the application of oxidation in our day-to-day life. Application of oxidation in day-to-day life. So there are so many things, they get oxidized and they get what, corroded. Some metals are there, some metals that itself oxidizes with the other substances and they get corroded, that is called as corrosion. I'll write some metals which react with oxygen, moisture and acids and get corroded, then it is called as a corrosion. Now this picture, first picture you can see, no, that is nothing but copper that turns what? Green color. Okay, when it is corroded they turns green color. And this one is a silver, turns black color. This one is green color and this one turns a black color. Okay, and this is nothing but iron turns brown color. Okay, so this is corrosion. Now how to prevent corrosion? I'll write here: prevention of corrosion. So first one is painting. You can paint the metals, and you can oil the metals. And third one, greasing. Okay, grease the metals, GASE. Okay, wait, I'll write here, spelling is mistake. Greasing. And fourth one is galvanization. And fifth one is alloying. Now galvanization is nothing but apply the coat of zinc. Okay, galvanization is nothing but apply the coat of the zinc on the other metal is called as galvanization. Alloying is nothing but mixing of metals. Mixing of two or more metals, that is called as alloying. Okay, greasing means applying grease to the machines and all, or the vehicles, machines, engines and all, no, that is what called as greasing. Oiling. And next one is painting. Galvanization is nothing but apply the coat of zinc. Alloying is nothing but the mixing of two or more metals to get a desired metal, that is called as a alloying. So okay, next one, that is about the corrosion. Next one, here you can see the picture. There one girl is holding a hand to her notes, isn't it? And next one, chips picture you can see, and inside of that more gas is there. And what happened here, maybe the food is spoiled, isn't it? Food is spoiled here. Now why the food get spoiled? Now what it is called as? That is called as rancidity. Okay, rancidity. If the oiled food or any food, okay, so or baked food is spoiled because of reaction of it with oxygen, then it is called as a rancidity. Now what is rancidity? If the oiled food or the baked food that is spoiled because of the reaction with oxygen, then it is called as a rancidity. Now how to prevent the rancidity? Prevention of rancidity. So that is nothing but closing the lid of the container tightly. ಸರಿಯಾಗಿ ಮುಚ್ಚಬೇಕು. ಮತ್ತೆ then supply of nitrogen or argon gas to the packets of the chips, such things and all, and adding antioxidants to the food item. Okay, antioxidants to the food item is called as a prevention. These are the prevention of the rancidity. I hope this much you understood. Types of reactions we learned clearly, and everything we learned. Thanks for your time. If you have doubt, please go through a video once again and study. Keep studying, don't waste your time. So thank you. And if you like the video, please like it and share it with your friends and subscribe our channel. Thank you.